Hi, good morning. Thank you for attending another TPC training webinar. This time we're going to talk about PLCs. First, a couple of housekeeping items. At the end of the presentation, we're going to have a chance to answer your questions. So on the GoToWebinar bar there, it should be on the right-hand side of your screen. There's a little question bar. Please type your questions into that, and we'll get those answered at the end of the presentation. The number one question we always get, however, is, can I get a copy of the presentation? Absolutely yes. At the end of the presentation, there will be a chance for you to get a follow-up email from us. Just take that email, respond to it with a request for the presentation, and I will send that out to everybody. You can also get a copy of the video. We are recording this presentation, so if you want that to share with your staff, I'll show you where we can you can access that. We put it on our Vimeo page, we put it up on our YouTube page, and we post it on our website as well. So you'll have access to that. With that, I'm going to turn the presentation over to Joe Doolittle. Joe.
Yeah, thank you, John. And again, thank you for participating in another TPC training webinar. Today is the PLCs for non-programmers, but you know, we've got a course for programmers too. So this course is for non-programmers. This is a great introductory course, great for professional development of your team. There again, I just wanted to mention this is who I am. I'm a U.S. Navy retired chief electrician. And I showed a picture of a carrier there, and that's where I used to live for a few years. Done the destroyers and frigates. I'm 100% familiar with the industrial electrical, including PLCs and variable frequency drives and whatnot. So as we go through the presentation, we'll be talking a lot about industrial electrical. And that's just a little bit of my background there. During the webinar today, we'll be discussing the PLC overview. And as we go through this, you'll see the hardware, electrical circuits, and schematics. This is a great course for the introductory. We go through wiring diagrams, schematics, documentation. And even if you're not familiar with basic electrical, we start off there, make sure everybody has a basic understanding of the electrical field. Safety is our number one concern, so we'll discuss a little bit about the NFPA 70E with regards to the programmable logic controllers. We'll talk about input modules, adding input modules and output modules, and all the requirements it's going to be to add those particular devices. Well, I think the students will really enjoy the programming of the basic instructions. This course is targeted for the hands-on application in the PLC. So once we get the basics of the programmable logic controllers, we'll get into some basic programming. Students really have a lot of fun. I did a class the other day with some of the medical people and some of the water treatment plants and whatnot. PLCs, basic instructions, the students actually have a lot of fun programming these. And as simple as from a garage door to batch processing, it could be a cement plant, could be many, many different applications. We'll talk about processor memory and words and bits and bytes and program scans. There will be a lot of information put out over the next couple of days, or the next 2 days or 4 days, depending on which course that you take. And I always feel that this is a shared responsibility between the instructor doing his part and the student doing their part. So it's going to be an exchange of information. It's not just an instructor showing slides. This is an interactive course where you get your hands and you actually program and understand the PLC. It's not just, it's lecture in a sense, but it's also keyboard and programming too. It's a hands-on, use a multimeter, checking your inputs, outputs. You will thoroughly understand the programmable logic controller when we get done with this course. All PLCs have timers, counters, and data instructions, and whether it be a count up counter, count down counter, PLC timers, time up, time down, all types of timers and counters and how they interact with one another. The best part about this particular course is the troubleshooting. Once we understand how PLCs work, we'll be able to troubleshoot them quickly. That's one of the benefits of this course, is the ability to respond quickly to any problems, whether it's a water pump or whether it's a ski lift. All of these have PLC industrial controls, or maybe it's manufacturing. We'll talk about installation, startup, maintenance, temperature, altitude, seismic zone, whatever it takes wherever you're at to install these things properly so that they're not affected by any of those things. Communication, we'll talk about Modbus, Profibus, RS-232, 485. We'll make sure we're able to communicate. We have an actual PLC, or actually 2 or 3 PLCs of different manufacturers that we'll be able to communicate with. And that's one of the key things, is communicating with these PLCs. Once you can communicate, and we will do that. And that's one of the things that we really take our pride in, is the hands-on aspect of this. When we connect up to the PLCs, we get all the basics done, and then we actually look at the program as it is operating. This is a critical point in this PLCs, is being able to communicate with the network. We talk about real-world applications, and as a matter of fact, in our simulator, we go through several different real-world applications, and then sometimes the students will come up with, what if maybe it's a ramp or a hoist or something like that. So we go through whatever different scenarios you want to go through, we can do that. We will make these on our, not only do we have simulation software, but we also have an in-classroom PLC that we utilize. So you will get the hands-on that you're looking for. All the different parts, we ask that you memorize a few things. Like I said in the beginning, you have to do your part, and I'll do my part, and you'll know the PLCs from memory. We ask that you memorize certain things so that when you have a problem, when you're called upon, you'll be able to know instinctively which area to go through. Am I going to have an input problem? Is it a communication problem? Is it an output problem? Is it a temperature problem? You'll definitely know PLCs when you get done. We go through a little bit of the history too, back in the 60s and 70s and 80s, when we went from relays to PLCs. Just about all process control, manufacturing, security, fire, HVAC, ski lifts, manufacturing, power plants, they all have programmable logic controllers in them. And we go through many different scenarios, whether it's filling a bottle or filling a jar of mustard, or maybe it's building automation with your SCADA system, supervisory control and data acquisition, whether it's a 4 to 20 milliamp signal, a 0 to 10 volt signal, or maybe we're just got a cooling tower we need to maintain water level in. We go through all of these different scenarios. And I know it sounds like a lot of information, and it is a lot of information from start to finish, from time class starts until 4:30 in the afternoon, and sometimes we go through lunch. It depends on the students. There's a lot of information is exchanged between us. We look at the CPUs. We understand the circuit cards. We know what we're looking. We're really lucky here at TPC training that we have seasoned professionals that have put their hands so they understand exactly what they're looking at. You see the panel there on the left. We know what all these lights and indicators mean. And at the end of the day, you will also. Now, this is a Allen Bradley system we have here, but we also talk about the Siemens systems, Automation Direct, Cutler, Hammer, any manufacturer. Obviously, we can't cover all the manufacturers, but we have a workbook that comes, and you'll see there on the right, it says workbook page 4. workbook comes with this. So we try to cover as many different manufacturers as they are. I call it form, fit, and function. All of these different manufacturers essentially do the same thing, and we go through as many as we can. And I'll send out an email prior to the course, and I'll say, which one do you have? Which one would you like to go over? So we go over the one that we go over, but if you have a Siemens and you want to know specifically on that one, we'll address that for you too, because it benefits the class too, not only knowing one system or one piece of software, but many different ones. So it's a very active class. We certainly hook up to the computer and program these. We do it a couple of different ways, whether it's a handheld device, there you see on the left, or by your laptop. And the cool thing is we have the software and the cable, and we actually program these with you. And some of these are password protected too, and as they should be. We talk about relays, relay logic, and you know, in the form of professional development, we have to keep up with technology. Yeah, there's relays out there, there's no question about that, and we do talk about relays and how they work, but in every growing company, we're going to have to stay in the 21st century, and PLCs are in everything these days. And you can see from the speed of these things, from 20 milliseconds right on up to a second. Very, very, very quick, the PLCs are. We'll list and understand the functional parts. In fact, we all ask that you memorize the parts of a PLC so that we know what we're looking at, and identify what all these indicator lights are. You open up your panel occasionally and you see all these blinking lights, and some people are like, what do all these lights mean? I can assure you, after a couple of days with me and my contemporaries, you will understand what all these blinking lights mean. We'll talk about the parts of inputs and output modules and all the requirements and the advantages and disadvantages of small PLCs. Maybe it's a small application, maybe it's a car wash that is just, you have a small PLC for that little automation, or perhaps it's as large as a ski lift up on top of Lake Tahoe. We look at
so this is John. Can you go back to that last slide, please?
Yes, sir. Yes, sir.
Can you go through, talk about what those 4 parts of the I/O module part are?
Yes, of course.
Go through these points and explain that to our audience, please.
Oh, the 4 parts to a PLC?
Yeah, could you go through those points for us?
Yes, the 4 parts of PLC, and it's really important that we know this, is the inputs, the outputs, the power supply, the CPU, and then the way to program it. So it's really important that we know all 4 of those parts: the inputs, the outputs, the power supply, the CPU, and the way to program it. And one of the key points with these is the power supply. Could be 1 power supply, could be 2 power supplies, could be 3 power supplies. And it's really important that we understand what those 4 parts are of the PLC. Is that what you were looking for, John?
Yeah. If we could just go through, the slides and give a little more detail about what those are, in case we have any folks who are unfamiliar.
Oh, okay, yeah. So each of the PLCs have different parts to it. Like I said, inputs, outputs, power supply, CPU, and a way to program it. And so we have to make sure that we understand what we're looking at when we do look at those PLCs. I apologize, John, for going a little bit quick. I kind of moved through this. And what the power requirements are. What the voltage is. It could be 24 volts, could be 120 volts, could be 12 volts, could be 10 volts. And we go through each of those. In addition to that, we also go through multimeters too. We've all heard the term RMS, and what is that, and the different categories of our PLCs and whatnot, and the different categories of our multimeters. And what the advantages and disadvantages of small PLCs. Maybe you don't have enough inputs or don't have enough outputs. So it's really important that when we size these things, we have enough inputs and outputs to do the job that we want it to do. Is that what you were looking for, John?
Yes. We have some folks that have varying levels of understanding, so I want to make sure we meet everybody where they're at. That's all.
Yeah, perfect. It's so when we look at this cabinet right here, for example, so you can tell, or I can tell on the left immediately we've got some power supplies on the left, and like I said earlier, so when we first look at these components here, say, holy cow, what is all this? Well, we got power supplies there on the left, and then we got the CPU, the next one over on the right, and then we have some input modules, and we have output modules, and so on. But within each one of those input and output modules, we may have digital signals, or we may have an analog signal. Those analog signals could be temperature, pressure, level, position, but nonetheless, they could be a 0 to 10 volt signal or a 4 to 20 milliamp signal. And how we do this is we'll grab a signal. We have these in our simulators there in the classroom, is we'll take that 4 to 20 milliamp signal and we'll turn it into, say, temperature, for example. We may take the temperature from 0 degrees to 1,000 degrees. We'll be able to scale it. And that's the benefit of this course, is the fact that we can take it in whatever application that you have. Maybe it's a water tank that you've got, and you need to convert a mechanical signal, maybe it's water level or temperature, into a 4 to 20 or a 0 to 10 volt signal. Having said that, we need to decide, can we use a 0 to 10 volt signal, or can we use a 4 to 20, and which is best for our application? So we'll look at the pros and cons of those two different signals, and we'll be able to convert those mechanical signals into electrical signals, which will take us into our inputs and or our outputs. So it's a very comprehensive course, but I can tell you at the end of the course, you'll know these, as we're looking at this right now, we automatically know, and just like I had mentioned, we got the power supply, the CPU, the inputs, and the outputs, and then we better define those inputs and outputs right there. So when your student takes a look at this panel, they'll know right off the bat exactly what they're looking at and what to expect. One of the key points of a good troubleshooter is to be able to anticipate what he's supposed to get before he gets it, before he can land his leads, before he puts his meter on this thing or interpret what those lights are. He knows exactly, or she knows exactly, what he or she should get before he lands or her lands his leads on these PLCs. So this may look like just a bunch of wire to some folks, but to the trained person, it's very, very understandable. This happens to be an Allen Bradley PLC, and you can see they're kind of mundane in their appearance, but if you know what you're looking at, this is the heart of the system. Whether it's an elevator, an escalator, a ski lift, a manufacturer, robotics, a ramp or a hoist, or air conditioning, refrigeration unit, this is the heart of the system. All the inputs and all the outputs come into this little rascal right here. This is the Programmable Logic Controller. And we talk about the Allen Bradley, but we talk about other manufacturers also. Like I said, we take a look at the inputs and the outputs. And one of the key things on this particular course, like I said, is the hands-on. And you can see this output module right there, and you see all the different outputs, terminals, and the input terminals. And each one of those inputs and outputs have an address. So it's really important that we know what the addressing system is on these, and we will, and you will. They're all unique, but nonetheless, they still all have input and output addresses. We talked about that inputs and output modules earlier in the presentation, and this happens to be an input module. Now, there's going to be some electronics that we're going to have to deal with. We do have an oscilloscope that we do take a look at these inputs and outputs from an oscilloscope point of view, and we take signals and convert it AC to DC. We have to understand that process, whether it's AC to DC or DC to AC. So we do talk about the fundamentals of power conversion also. And we have rectifiers changing AC to DC. And this is all part of our workbook. So by the time we get done with the presentation, the hands-on, the workbook, and the programming, it turns out to be a very, very rewarding course. We got a voltage input, full wave rectifiers, and we talk about diodes and filters and capacitors and inductors and all kinds of stuff, and power factor, kW, kVA. Very, very informative course. We talked about optical couplers. That's that little LED, that light emitting diode. That's what tells us we have an input or an output. And the best part about this is we put a meter on it. When you get done with the course, you'll know exactly what you're looking at. Do we repair circuit cards? No, we do not. But we can tell if a card is good or if a card is bad, that's for sure. So it's just effective troubleshooting, knowing what we're looking at. That's the whole key behind this course in itself, is knowing exactly what we're looking at and how to troubleshoot these little guys. And we talk about triacs and diacs and SCRs and all kinds of these switching devices there. You'll understand it's a lot of information in 2 to 4 days, depending on which course you've selected. This is a Direct Logic PLC, just another manufacturer. Automation Direct makes this guy here. But you can tell we've got a PLC or a processor. We have some inputs and outputs, and when your folks take a look at this thing and you see some indicator lights, you'll know exactly what you're looking at, and the ability to anticipate what you're supposed to get before you get it, so you know what lights are supposed to be on and you know what lights are not supposed to be on. There's fault lights, trouble lights, what force means. Perhaps we don't want to use the force. That means we can make things happen that shouldn't really happen. And so we don't use the force very often. We got battery backups, inputs and outputs, and then those doors open up for you. And you can see there's a key switch on there. Maybe we don't want everybody into the PLC. Maybe you have all your output lights on or all your inputs. The ability to anticipate what you're supposed to get before you get it. That's the key to a troubleshooting technician. And we'll go through the lights to see what can cause these problems. How come it's not running? How do we lose communication? Do we need to force the I/O? Is the internal battery, how long does the internal battery last? And you notice on the right there it says DC sync. We'll talk about syncing and sourcing. It's very, very important that we get the polarity correct on these things. In any circuit, just like jumping your car, when you jump your car, if you get the polarity wrong, bad. On these PLCs, it's not necessary to where it would catch fire or anything like that, but it won't work properly. So we got to talk about syncing and sourcing. It's very, very important. And having said that,
can you talk about what these lights mean?
Say again?
Can you briefly discuss what the lights on the front do mean?
Oh, absolutely. So on the run light, so there's different modes these CPUs have. So if you're in the program mode, you wouldn't have a run light. The communication, so if you got comms or communication between the RS-232 and 485, we would have communication. So it's very, very important that we have communication. Okay, and then in the run light, perhaps there's a fault, and you can see the CPU fault. That means that something has been shorted out within this one of the inputs or output modules, or within the CPU itself. And then that light there, it says force it. So we would not want to use the force. I don't encourage using the force. And what the force means, it says don't start that generator. The PLC is programmed not to start the generator unless we have oil. Well, you can bypass that, and that's called the force. So we wouldn't want to force any of the I/Os. There may be an occasion to force things, but we would encourage you never to use the force to start something that shouldn't be one of the prerequisites are not met. And then obviously there's an internal battery on your CPU, usually good for a couple of years, but we'll see how to check that battery to make sure that we don't lose it. Because on occasion you're going to lose utility. And on that occasion, that's when we want to make sure this PLC has a battery. So we want to check that battery every 2 years, or depending on the PLC, is the frequency of how often we check that. So we have the run light. That's when our PLC is turned on, and then the communication light. And then if there's a fault within the CPU, so maybe we do something logically that doesn't make sense. Maybe we don't have an output, but we've got inputs, or vice versa. That would cause us a CPU fault. It doesn't understand. If it doesn't make logic sense, then the CPU can, will, and does generate a fault. So if you could cause a fault if you program this guy improperly also. Okay. On occasion, you're going to have these guys right here. These are called dip switches, dual inline purpose switches. We'll see how to set these up. Not all processors have these dip switches, but it's the details that count on these PLCs. It's these little devices right here that we need to know how to set, when to set them, and when not to touch these things. This is the technician's combination, if you will. We'll talk about the small ones and IOs. We already know IO is inputs and outputs. And so we'll talk from the small guy to larger PLCs. Like I said, any piece of equipment, from an HVAC system to a security system to manufacturing system to industrial automation, whether it be robotic or whether it's just a car wash, they'll have different inputs and outputs and different number of inputs and outputs, and which one to select and which one to buy. Yesterday we had a class, they were doing a PLC changeout, and we had to talk about memory. What size memory do we need? How many bits and bytes and words, and how many inputs and outputs? And so we can size one of these things pretty good if we know what the process is.
Joe, can you talk about some of the examples for each one of those different input outputs on that previous slide there?
Oh, different inputs? Oh, it could be any number of things. So let's pretend like we're a car wash. Just want to keep it simple. So we have an input, right? The car shows up to the car wash, right? It hits a little light. We've all driven into a car wash before. That would be an input. When we show up, when we drive over a ramp, there's going to be an input, a pressure switch, a micro switch, a limit switch. Maybe it's a door switch. Maybe it's a level switch. Any type of switch would be an input. Okay. So once we get to the car wash, it goes through and it senses the car is present. Great. It starts a conveyor in a certain amount of time. Maybe we want to set that time for 2 minutes. But wait a minute, we want to count the number of cars we're going to go through the car wash. There's a small PLC, and it's probably that first one there, probably a micro for 32 inputs and outputs to take that car through the car wash. Maybe it's got to start a pump for some soap. Maybe it's hot water. Maybe it's cold water. It kind of sets it up. And what we'll do is we'll program this. This is a key part of this course, is being able to program. The customer is going to say, I want this to do this particular function. I need hot water for 30 seconds. Oh, wait a minute. I want 180-degree hot water for 30 seconds. So not only can we set the temperature, but we can set the time. And how many times how many cars did go through this particular car wash? Then it hits another switch, another input. It says we've completed washing the car. Now we need to dry the car. And so as it goes through the process, this PLC is doing exactly what we're programmed to do. Inputs, switches, buttons, temperature switches, outputs, solenoids, indicator lights, relays, contactors, and whatnot. So, and you can have any number of these inputs and outputs depending on the application. So a car wash might be 32, a ski lift might be 1,000, but nonetheless, got to have inputs and outputs. If that car or that that buggy that's going up the ski lift, if it opens the door, it's going to hit a switch. We have to shut that unit down because there's been an obstruction in the door. So any of these inputs and outputs could be any number of things, but they're all going to be switches, coils, solenoids, or indicator lights. Those typically are inputs and outputs. I mentioned earlier, going to be a 4 to 20 milliamp signal, or a 0 to 10 volt output or input could also be an input or an output, depending on the application. Now, each one of those symbols, each one of those, and John, thank you for slowing me down a little bit on that. It kind of jumps right into this. So all of those inputs and output signals have to be told what to do in the logic circuit. So in this logic circuit, each one of those signals will be represented by a symbol, whether it be an input or an output. Those inputs, as you can see, and let's take a look at rung 1, for example. Input, card 3, terminal 2. Everybody take a look at that. That's input, that's an input, and if you see on the right-hand side, that's going to be an output. And the ability to read these drawings, that's going to be a key part of this course, is interpreting these drawings. And there'll be much more complicated drawings than this. I just wanted to start. In fact, I think I have another slide that are a little bit more complicated. So the output, so we got outputs on the right, output, card 2, terminal 3, exactly where to go. They may look all the same, but they have a different address. So each of those, as we go through the car wash, each one of those devices have a specific address, and we'll do plenty of programming, enough to where you'll be able to be off and running when you get out of this course. Like I said, some of these drawings can be complicated, but what we do, we take our time and we go through each one of these drawings. And if you say, Joe, this looks really kind of busy, but you know what? We separate it out. We take between power and control. It looks kind of busy. It certainly does. But one thing I found when we do these drawings, and we usually do them in the morning of the second day, is we go through each one of these drawings, line by line, nice and slow, so that they're able to look at each one of these rungs, because each one of these rungs is an activity or a segment, if you will. And we take this one by one by one by one, and we go through it slowly. So when your associate gets out in the field, he or she is able to read these drawings. Now, this is only a 2 or 4 day course, that's understood, but we set the baseline for understanding and reading these ladder diagrams. It looks really busy, but when you take it apart, rung by rung by rung, let me go back. I didn't want to do that just yet. When you take these apart, rung by rung, and then device by device, when your associate gets out there into the field, he or she knows what they're looking at. Now, should there be a little bit of prior experience understanding some of this? In some cases, yes. In other cases, no. I take the time. TPC training has been known to take the time. Come in a little bit earlier, and let's go over some of these drawings. So if a student doesn't get it at first, that's okay. We'll spend some lunch. We'll spend a little time before class or after class. Our objective is for you to understand the material, and we do that. So we just don't give you a drawing and assume that you understand it. We go through it. So when you get out of this course, you understand PLC start to finish. We'll talk about ladder diagrams or ladder logic. Sometimes it's difficult to understand the difference between a schematic. If you remember, a schematic is electrical location, wiring diagram is physical location. And then we have a ladder diagram, and then we have one line diagrams. We have a buffet of different diagrams. We have to go through those. And you might be thinking, Joe, we've gone through a lot here in this last half hour, and it is a lot. But when we take it in 2 to 4 days and break it down, the time is used so effectively from 8 in the morning till 4:30 or 5, or however long it takes to get through these courses to where you understand it. No student, even if a student might be kind of new to the field, we take the time to to help them through it. Maybe it's Ohm's law, maybe it's a multimeter. We certainly take the time with our students. We'll see what the input instructions are. We saw the ladder diagram before, and how to interpret it. What does it look like? What should it look like? What's an input look like? What's an output look like? We're going to give it a set of instructions, and they say instructions because that's what it is. We want that car to go through the car wash in a certain amount of time. We want the hot water or the cold water, or we can't operate the lift unless all doors are shut. The number one thing is a safety. Safety of all personnel is our number one consideration here at TPC training. And we go through the lockout, tag out, the NFPA 70E. Now this is not the NFPA 70E course. We do offer that course also. It's not only recommended in some areas, it's required in some areas. So we do talk about safety. When do we need PPE? At what voltage do we need PPE? What gloves to wear? How to read, even how to read our labels. So when we look at a panel, we can see and understand what those labels are, that limited approach, that restricted approach. At what voltage do we need PPE? What type of gloves do we need? Am I qualified to work on this? Very safety. So we'll spend enough time to make you understand when is PPE required and when is it not required.
Joe, can you explain briefly what would be required for limited approach and restricted approach?
So certainly, limited approach and restricted approach is, okay, this is fine here. Limited approach and restricted approach are different boundaries for different voltages. So you'll see restricted approach is for the qualified person, limited approach is for the unqualified person. So we have to make sure that we're qualified to work on your piece of equipment. So if we wouldn't want, we're going to train you in PLCs, no question about that. We're going to want to make sure that you're qualified. And those boundaries, when you look at your labels on your piece of equipment, on your power panel, where you work, that's the term that's used on those labels. Limited approach, restricted approach, qualified and unqualified. So that's what that means. And as far as distances goes, it depends on the voltage as to what those distances are. And it also has to do with fault current and clearing time. So depending on the fault current and the clearing time will determine those distances. I can't say 40 volts the distance is this and the 40 volts the distance is that, because it depends on the fault current and clearing time. So each of those are different. And if you look at the NFPA 70E, and I believe it's table 130, I know it's table 130. I'd have to look exactly. That table will give you exactly what those boundaries are. And we talk about that. We want your team members to be safe on this. And so we'll talk about labels and what PPE to wear. So that restricted approach, limited approach, it's just about qualified, unqualified people. Is that okay, John?
Yes, thank you.
We'll talk about arc, shock, and blast. We're going to be working, these PLCs control all types of voltages. And although most of these PLCs are 24 volts or 120 volts, whatever that is, but we're going to control some higher voltages. So we talk about safety is the number one consideration with at TPC training, or TPC training. OSHA requires only, and I mentioned qualified people. So we talk about qualified and not qualified, and who qualifies us. The employer qualifies us. So just because you go through this course doesn't mean that you're qualified. Each individual company will determine if their team member is qualified or not. So we have to make sure, right? And it says PLC software allows overriding of interlocks called forcing and disable. So we talk about when we can do that and who's qualified and who's not qualified. The employer's qualified people. You'll understand PLCs, but we've got to make sure that we're qualified to work on the equipment. Talk briefly about PPE, what to wear, flame retardant clothes, Class E hard hats. When are our gloves tested? How often are they tested? Every 6 months. How often are they inspected before each use? Make sure that we have the right classification of gloves, the right rated clothing.
Joe, can you talk about each one of those PPEs to kind of explain some of those in case anybody out there isn't familiar with those?
Oh, with our PPE, NFPA 70E requires that 50 volts and above we wear PPE. So we have to make sure that when the member is working on these PLCs, now these PLCs, some of them are 10 volts or 24 volts, but they might be 125 volts or 240 volts in some cases. So we have to make sure. So we got the balaclava hood, so that's PPE category 2. So if you look at the NFPA 70E, the table 130, it tells us, so that's category 2. This gentleman that you see here, he's wearing category 1 PPE. So each of the team members that come to TPC training, we go through exactly what is required for category 1 up to 240 volts or category 2, 240 to 600 volts, whether it be the balaclava hood for 240 or just a category 1 that you see this gentleman right here. So the different voltages would determine the type of gloves that you have. In your case, category 1.
And that Z462 table, that's the Canadian standard, correct?
That is a Canadian standard. So and that brings up another point. Thank you, John. So we do go through the Canadian standard. We look at the Canadians to know that there's a difference. And the NFPA 70E, that's our national. We also briefly take a look at the ISO, the international standard. So we do cover here in our country the NFPA, but we also look at Canada and also the ISO, the international standards. And having said that, not to digress back, but in our circuit drawings that we've got too, we've got the international standards too. So we touch base when we look at our drawings, the different circuit designations for not only here, our products manufactured here, but we also look at products manufactured in other countries so that we are able to read their drawings effectively too. So we not only look at our drawings and in regards to safety, but also drawings from other countries too, to make sure the circuit designations are different. So the answer is yes. So that's Canadian, and then the NFPA here, and then the ISO, the international, and then also the different circuit designation internationally too. So like I said, when we get done with this PLC course, not only will you understand PLCs, but we're also going to take a look at those international. Now, this is not a safety course. I don't want to mislead you and tell you this. We do offer the Arc Flash course. It's a great course in addition to this, but we do touch on the safety, what's required. So we do offer the TPC Arc Flash training, and it goes a little bit more into detail, or a lot more into detail of the NFPA 70E. Different IOs, different power supplies, and yeah, we talk about Ohm's law. We're gonna do current, voltage, resistance. I always tell the students in the beginning of the class, you're gonna need a calculator. Yeah, so we definitely do a lot of math in this particular class. How much power? Speaking of which, I'd just like you all to write this down if you could, as far as a kilowatt hour. I'd like just everybody to take away, just so you know what a kilowatt hour is. So if you could write this down, it's 1,000 watts for an hour. 1,000 watts is a kilowatt hour. So if you have 10 100 watt light bulbs running for an hour, that's a kilowatt hour. And look up in your area, what's it cost for a kilowatt hour? We have to address the financial end of this thing too, and we do how much things cost. So a kilowatt hour is 1,000 watts for an hour. There again, master control relay, that MCR, very, very important. When we hit the emergency stop, we have to know that this thing is going to shut down. So that MCR is very, very important. It's a master control relay. When we hit the emergency stop, when we hit that red button, we have to know that this thing will shut down. When can we use it? When should we use it? When it's required to be used? We're going to go through the software, the rack. I could go on and on and on this PLC. If there's an open slot, do we have enough current left to be utilized? And like I said, how much all these things cost. All the different instructions, I could go on, and we've got a nice guide that goes through all of these different instructions. It's almost like a different language. Ones and zeros, binary, hexadecimal, decimal, and ORs, and I think the next slide is all about the math. We're going to be doing some math for a couple of hours. Inputs and outputs, analog and digital.
Hey, Joe, can you go back to that slide real quick and talk about what is the main differences between analog and digital and what some of the questions are that people could probably be asking before adding that I/O?
Oh, okay. Yeah, the difference between inputs and outputs to the PLC. So on the inputs, like I said, when we got the car wash, when we hit the car wash, that's going to be an input. When the car lands on that switch, that's an input. When that light comes on, it says green or stop or yellow or go, that's going to be an output. And the difference between an analog and a digital signal, one is variable. Maybe it's a temperature on your thermostat. That would be an analog signal. That's going to be a variable. That's going to be from 0 degrees to 80 degrees. That's an analog signal. A digital signal is yes or no. Is the thermostat on or off? That's a digital signal. Is the temperature in the room between 0 and 80 degrees? That's an analog signal. The difference between an analog and digital signal, one is yes or no, on and off, a 1 or a 0, and an analog is variable. And that analog signal also, not only is it a variable signal, but it will be a converted signal. That water level or temperature will convert it from a 4 to 20 milliamp signal. And I know that sounds like kind of a complicated term, but we put it in a simple way to convert milliamps from a mechanical signal, whether it be temperature, pressure, level, or flow, into a milliamp signal into the PLC. The function of the processor, it takes all the different inputs and all the different outputs and it compares them. And it compares them in the program files. We'll have to go through the input data file, the output data file. We mentioned earlier about counters and timers, count up timers, count down timers, enable signals. Those are all in the data files, and we're going to go through each one of those. It is a lot. And then once we compile all that data, all the inputs and all the outputs, the processor has to do what they call as a program scan. It analyzes it to see what instructions have we told it to do. We have to have this input, this input, this input. It's just like when you get in your car. So your car won't start unless your car is in neutral. Your car won't start unless your foot's on the brake. Your car won't start unless you're sitting in the seat. Whichever the prerequisites are, that's the program. We've programmed it to operate that way. You can't start your car, and so there's a small PLC in your car. Or maybe it's the light, the dome light in your car. That dome light in your car comes in if one door is open, or if the other door is open, or if the other one. So there's AND circuits and there's OR circuits. There's 2 or 3 different types of memory. There's word, there's bits, there's bytes. How many bits in a byte? How many bytes in a word? And we go through that. It's an awful lot of information in a short period of time. But as we go through the course, we make sure that the students understand each of that before we move on. Yesterday, there was a student who was having trouble with bits and bytes. And we just said, hey, let's write this down and make sure that we understand that there's 8 bits in a byte and 2 bits in a word. And that's as far as memory goes, it's all about the number of words in a program or in a PLC that determines the size of the PLC. It was a great course we had yesterday.
Joe, can you briefly go through those bullet points, though?
Right here?
Yes.
Okay. The function of the processor is to take all of the inputs and all of the outputs and compare them in a certain amount of time. So if we're counting apples, and it would take apples, maybe it's after 500 apples, we need to open a box. And so the function of the processor is take all the inputs and all the instructions it says, maybe it's a solenoid valve at the end of the day, and execute that particular instruction. That's the purpose of the processor, is to execute those instructions. Within those instructions, you have input files. And within those input files, it might be a timer. We need to have so many apples in a certain amount of time. And so within the processor, there's files. Input files, timer files, counter files, fault files. And within each one of those files, or within each one of those programs, there's a file. It's like a file cabinet. And each one of those files, in each cabinet, which would be the processor, and each of those cabinets, there's a file, whether it be an input file, output file, timer, or counter files. And within each of the counters, let's take a counter, for example. So we need to know when the counter is activated. That's a file. We need to know when the counter is counting. That's a file. We need to know when the counter not only is counting, but when it's done counting. That's a file. We need to know not only is the counter counting, but have we gone over the count? That's a file. We need to know not only is the counter counting, is it under a value or not? That's a file. So within each of the program files, there's sub-files within each one of those for each particular device. And that's what's kind of cool, because maybe you want to know if a device is counting. Maybe you want to know when it's done counting. Maybe you want to know if you have a preset value of 10 and you go over that, we can execute a command, we've gone over or under. Maybe you want to do maintenance on a piece of equipment and you said you want to, after 15 starts, you want to do maintenance on a piece of equipment. You need to flag that piece of equipment after it's run for 150 hours or 15 starts or however you want to program. All of those files or within the processor or within the program files. So each device has its own set of program files, whether it's a timer or whether it's a counter or whether it's an input or whether it's an output. Okay? Types of PLC memory. Like I said, you have binary, octal, or decimal type of memory. So it might be as simple as a barcode. A barcode is black and white, ones and zeros. But then again, it might be an analog signal too. So there's 2 or 3 different types of memory within the PLC. And this is, I mentioned earlier, it does a PLC scan. John, we're moving right along here, my friend. We got the, it takes, and so when we get done with all of our inputs and outputs and program files and data files, the computer, and that's what a PLC is, it's an industrial computer. It takes all of our inputs and all of our outputs and it executes an instruction. You can see the inputs, takes all of our inputs, each ladder rung that we looked at earlier is scanned using the data image file or table files, resulting in an output. Then the output image file is transferred to our external output circuits, turning things on or off, whether it be a light or a solenoid. We do talk a little bit about grounding and proper grounding. It's really important that we ground things properly. With all the, what they call EMI, electromagnetic interference, it's really important that we have proper grounding. Some people ignore the grounding, some people paint over the grounding. It's just real important. And you can see that we go through what to do and how to hook the grounds up and what not to do hooking the grounds up. So you can see from the start to finish, from basic electronics all into the program files. This PLC course is a well-rounded, well put together course that you'll know PLCs from start to finish, including the grounding at the very end.
All right, we're going to give some folks some time to add some questions. I know we glossed over a lot there. It is a ton of information. But if you have any questions, please put those into the question bar on the right-hand side. Also, if you need a copy of the presentation, we're happy to provide that to you. Just respond back to the email at the end of the presentation. And if you need a link to a recording, please do that as well, and we can get that out there. So we'll kind of wait on some questions. Joe, do you have any last-minute thoughts on some key takeaways that people need to know about understanding the basics of what PLCs are? What's some last bit of nugget of knowledge that people should know?
The number one thing is just about all of your rotating machinery has PLCs in it. And in the effort of professional development and key skills is knowing the PLCs. One of the things we want to do with the PLCs is reduce the need for outside sources to come to your facility. There's not a need for a ABB rep or somebody else to come in. Once we understand the PLCs, you can do 99.9% of this work in-house. And that's what TPC training does. It helps you eliminate calling out for outside help. And understanding these PLCs is definitely a way to do that.
All right. We actually went through a bunch of questions while we were going through the presentation, and I don't see any more coming in. So I think we're going to leave it at that. Everyone, thank you very much for attending. We will be having another webinar next month. This one will be on variable frequency drives, so you keep your eyes and ears open for that, and we will see you then. Thank you very much.